Assalamualaikum. I am a student of Poly KK. My name is Muhammad Izzharudin bin Awang Ibrahim and my registration number is 07 DTK 16F1006. As you can see, this is how it is spelled. Today we're going to present topic 1 in subject CMOS, and the code is DEE6113. The topic we're going to present is introduction to integrated circuit. Okay, first of all, we must know what is integrated circuit. The short term for it is IC. Sometimes it's called a chip or a microchip. It is a semiconductor wafer on which thousands or millions of tiny resistors, capacitors and transistors are fabricated. The advantages of integrated circuit is has a very small size, 100 times smaller than the discrete circuits, and lesser weight. A large number of components can be packed into a single chip, so it means the weight is reduced, and the cost is also reduced. The mass production technique has helped to reduce the price. It is also high reliability due to the absence of soldered connection. It is the next advantage of it is it has low power requirement. As the size is small, power consumption is less. It is also easy to replacement in case of a failure chip, like that. Next, we will do a comparison I will show you the comparison of IC and discrete circuits. IC can work on low voltage, while discrete circuit require comparatively more voltage. Second comparison, IC can handle limited amount of power, while discrete circuit can handle much more power than IC. The next comparison is IC are very small in size, while the discrete circuit require larger space because the size is not small of the component is not small. Next, IC is more cheaper, while discrete circuit are costly than IC. The last comparison is IC has a complex circuitry on a chip and may be used to obtain improved performance characteristic, while discrete circuits, the performance is not so good. Okay, next we're going to show the package for IC. The name is dual inline package. Dual inline package is an electronic component package with a rectangular housing and two parallel rows of electrical component connecting pins. As you can see, this is the image of this package, and it got a lot of parts.
Good morning, my name is Shafiq bin Roslan. My case card number is 07 DTK 16F1007, and I will be continuing to present the functioning of IC packages. In electronics manufacturing, integrated circuit packaging is the final stage of semiconductor device fabrication, in which tiny block of semiconducting material is encapsulated in a supporting case that prevents physical damage and contortion. In the case known as a package, supports the electrical contacts which connect the device to the circuit board. the integrated circuit package is responsible for keeping the chip safe from all sorts of potential damage. The package must resist physical breakage, provide airtight seal to keep out moisture, and also provide effective heat dissipation away from the chip. At the same time, it must have effective means of connecting to a PCB, which can change drastically depending on the package type. Next I will be discussing about the scale of integration. The number of components fitted into a standard size IC represents its integration scale. In other words, it's a density of components. In the early days of simple integrated circuits, the technology's large scale limited each chip to only a few transistors, and the low degree of integration meant the design process was relatively simple. Manufacturing yields were also quite low by today's standard. As the technology progressed, millions then billions of transistors could be placed on one chip, and good designs required thorough planning, given the rise of field electronic design automation, or EDA. Now, as you can see, this is a table on the scale of integration. Start from SSI, or small scale integration, introduced in 1964. Transistors can range between 1 to 10. Next is MSI, medium scale integration, introduced in 1968. The number of transistors range from 10 to 500, with logic gates of 13 to 99. Next is LSI, large scale integration, introduced in 1971. Number of transistors ranges from 500 to 20,000, and logic gates number ranges between 100 to 9,999. And next is a very large scale integration, or VLSI, introduced in 1980. Transistors ranges between 20,000 to a million, and logic gates number ranges between 10,000 to 99,999. And finally is the ultra large scale integration, or ULSI, introduced in 1984, that contains more than 1 million transistors and logic gates, and more than 100,000 logic gates. Okay. Next, we'll be discussing about Moore's law. In 1965, Gordon Morse predicted that the number of transistors can be integrated on a chip would double every 18 to 24 months. Computing chip performance doubles every couple years, or 18 to 24 months. Amazingly visionary million of transistors or chip barriers was crossed in the 1980s. As you can see, around 2300 transistors and 1 megahertz clock, Intel 4004 in 1971, 16 million transistors for Ultra Spark 3, 42 million, 2 gigahertz clock for Intel P4 in 2001, and 140 million transistors for HP PA 8500. Although there are many more to be discussed in topic 1, unfortunately we have reached to our time limit of our presentation. So I hope you have enjoyed our time and understand much more about CMOS IC design. Thank you.